All right, so good morning, guys. So let's actually, remember we have started firm theory a little bit. So let's continue with the firm theory. I think today, this lecture and next lecture, we're going to finish up the production, okay? So remember it was very similar, so like all the concepts, so here's a little bit of a recall. So remember actually these concepts in firm theory and in consumer theory were very similar. So remember in the consumer theory we had the utility function, and then in the firm theory we had what? How did we call it? It was called production function, right? So it's so we denoted by an F, and so this is consumer theory, okay? And here we have the firm theory. Okay, so here, I think your book uses capital first, but it doesn't matter. You can change the order of the arguments. Okay, so this is actually f of Lk. So this was showing, remember, like with this much labor and this much capital, what is the maximum amount of output you can produce? So basically, it was the case, right? And then just as we had, for instance, the concept of marginal utility, right, in the consumer theory, we're going to have the concept of what? What did we call this? Del F over del L, del F over del K. So how did we call them? These were called marginal utilities. So we call them marginal products, right? Either marginal productivity or marginal productivity of labor, marginal productivity of capital, or marginal product of labor, marginal product of capital, okay? So just as we had the marginal utilities, here we have the marginal products, okay? So we basically have these, and then, so we actually said that remember consumer theory, were these positive, negative, how did we call them? So, but that's about the second derivative, right? As the first step, what was it? So we said that they're positive, and how did we call it? It was, they don't have to be, but we said if they're positive, we call it, there is this assumption on our preference that more is better, right? So basically, and well, here it makes, like, again, more sense that as you keep on using more labors, the contribution to the total output, right? So you can actually write it like this. This is better. This way you can see it better, right? So it means that if you hire an additional labor, it's going to contribute to your output positively. Again, it doesn't have to be the case, but most of the time, we actually assume that these marginal products are positive, okay? And then, as you said that, hocam, but there was this second derivative issue, as you were mentioning, right? Which was actually about the, what's happening to marginal utility again when, for instance, x increases, right? So these guys were, call it u of x. So this was u of y, and this was, call this f of L, call this f of k, okay? And then we actually, so that you would have, so these are marginal utilities, okay? So basically, and then we said that in the marginal, like in the consumer theory, we actually said that u of xx, u of yy, they don't have to be, but eventually, right, the contribution of, actually, if you want to have an extra unit of x, the contribution of that to your total utility is going to decrease eventually, right? It might not decrease in the beginning, but imagine that you keep eating, like you keep eating chocolate. Maybe at some point it's going to give you, the second one is going to give you, make you happier maybe than the previous one. But that's not going to be the case, like if you are talking about, like, for instance, the 1,000th bar of chocolate, right? So that's not, I don't know whether we have any, chocolate maniacs here, that they would still get some utility from the, thousands, of bars, but probably eventually, even for them, then for the 2000th bar, I think it's going to decrease, okay? So basically we called it, right, so these were called diminishing marginal utilities, okay? We said that. And here, again, in the firm theory, we can also have these diminishing marginal utilities. So we called it f of LL, f of KK. So basically these are the second derivative, okay? So you can actually call this like this, right? So this is actually del L squared. So this is basically del square f del L squared, okay? Whichever one you would like to write down. So this is basically, so it's actually the same concept here. So which means that if you keep on adding a worker, let's say to Mozart Cafe, because the capital, right, the space of Mozart Cafe, the tables, chairs, the ovens, remember whenever we say capital, we talk about physical capital, it's limited, right? So as you keep on, and don't forget that these are partial derivatives, meaning that when you take these derivatives, you actually hold the other guy constant, right? So basically, these guys are, just as we had diminishing marginal utility, we actually can have these guys negative, again, eventually. So it's also called the concept of diminishing marginal product or productivity, okay? So these guys can also diminish, okay? But remember then, I called you guys dismal scientists, remember? So if you consider yourself as an economist, you might, if you make this reference that economics is a dismal science, remember dismal meant pessimistic, right? So why we said that? Because it was due to Thomas Malthus, because he was very afraid that back then, of course there wasn't much capital, but actually he was afraid that there was land, right? Land is also an input. For instance, think of the agricultural production, right? What are the inputs there? Do you have computers? Yes. I mean, now, of course, you can have some sort of, but like if you want to produce tomatoes, what are the inputs? Seeds, yes.
Tractors.
Yes, again, there's capital, of course, tractors, but, not with tomatoes, right? You need labor and water, like raw materials, and where do you want to grow the tomatoes, right? Not in your balcony, right? You need some land. So, right? So, actually, unless you have, weird techniques, but now they're all coming up, we know. But imagine at his times, he was seeing that, there's this limited amount of land, but, people are actually growing, right? The population was growing, and it was growing at an exponential rate. So he was afraid that because eventually the worker productivity is going to fall, and we have the fixed land, right? Then in the end, there won't be enough food for people, right? Eventually, these productivities would fall so much that, we cannot feed the entire world and such. But remember, we actually discussed about this, and then we said that, Malthus forgot about this guy, capital, mostly. He mostly thought of it about land, but even in that case, right, so this could be the case, as we said, so f of L might decrease eventually, but this is under the assumption where you keep capital at a rate k bar, right? So if capital increases, okay, so you also need to look at this guy. When capital increases, this might have a positive effect on labor productivity, right? So what is this sign? If this sign is positive, as we discussed right before, then you don't have to consider yourself as a dismal scientist, right? We can be more optimistic, and then and which was actually the case, okay? So this was what he was missing, okay? Now, so you see that the concepts are very similar in many aspects. So there is another in firm theory, there's actually another concept that we're going to use. We didn't use it in consumer theory because it didn't make much sense there. But you'll see that it will have a lot of sense in firm theory. It's actually the concept of an average product, okay? So basically, so let's call this the average product of labor. So basically, it's going to be Q divided by L, okay? F of LK divided by L. Basically, on average, let's say at Mozart Cafe at Bilkent, on average, one worker is producing, how many salads, okay? So, or at Arçelik, an average worker is producing how many telves, right? Those coffee machines, Turkish coffee machines, okay? So this is called average product of labor, okay? And as you can guess, so let's call this average product of capital. So this is going to be Q divided by K, F of LK divided by K, okay? So this is basically the case, okay? So this is actually called the average product of capital. Now, what is the relationship between these guys? So basically the marginal products, right? So this guy and this guy. So let's try to see. So what is the relationship between MPL and APL? What is the relationship between these two concepts? Now, we actually did this with my 101 students. So we usually cover it, probably you guys covered it as well if you have taken an introductory econ course. But now in this course, you're going to see, I'll tell you the intuitive explanation and you'll figure this out immediately. But now we can actually, because now there is math, so it's going to help us. So you see that it would be, we can show this very easily, okay? But let's actually look at the relationship between marginal and average, okay? So intuitively. So let's do this. Suppose, let's say I read your exams, okay? We had the midterm exam. I read your exams and the average turns out to be, let's say you guys did very well. Let's say it turns out to be 65, okay? So suppose the average is, like 65. Then I figured out that I actually didn't grade one of your friend's paper. And let's say, he was a very good student. And it turns out that marginal contribution of that guy, so suppose that your friend got, let's say, 95, okay? So remember all this marginal concepts, right? If I add an additional, another one, what is, how much will it contribute to the total? Output, total, utility to total, right? So basically, so remember the average was 65, and then I figured out that your friend got 95, so like his marginal contribution to the sum of total grades would be 95, right? So what's going to happen to the average? It's going to increase, right? He's going to pull up the mean. So basically what's going to happen is that the average will, as you guys said, will increase, okay? So what's happening here, you see that when marginal is above the average is increasing, okay? Now, suppose that it was one of the lazy ones, okay? So the average was 65, but I figured out that he got 30, okay? So the marginal contribution is going to be 30. He's going to pull up the average or down the average? Down, right? So the average is going to decrease, right? So as you guys said. So you see that whenever marginal, the ones that you add to total, right, are actually below the average should be decreasing. So when the marginal is above the average should be increasing, okay? So suppose I have two curves. So let me try to draw this. Basically, so suppose this is the marginal product curve, okay? So which you would see, because we know that the marginal product is going to, if there is diminishing marginal product, it should decline eventually, but it might increase in the beginning. So it should be something like this, okay? We don't know, but suppose the marginal product of labor curve is like this, okay? So how would the average look like? So we know that, suppose I would like to draw the average here. Suppose so in this portion, suppose this is going to be my average curve, okay? So the average is actually below the marginal. So marginal is above the average. What's going to happen to the average? It will be increasing, right? So I should draw this like this. Okay, fine. And then it should be increasing. And then whenever, so suppose there is this part, I know that whenever marginal is below the average, average should be decreasing, right? So where will they intersect? According to this very simple logic, which we are going to show by math, but it should be, so it should be like, so this is the average product of labor. Where should they intersect? So it should, the average and marginal, the marginal should cut average product curve where? At its maximum, right? Because just imagine you don't know grandma again, right? So I think I didn't mention her, like a lot recently. So let's come back to the, like the basics, right? So if you want to tell to your grandma, you can say that, well, when marginal is above the average, average is increasing. When marginal is below the average, average should be decreasing. So here the function is increasing. Here the function is decreasing, right? So this is actually, right, so this is the place where that function reaches its maximum, right? So that's why the marginal product of labor should actually cut the average product of labor at its maximum, right? So you can get this, so this was intuitive. But now you can tell your grandma that now you know calculus and better techniques to show this. So let's actually prove this, okay? All these facts. So for this, let's actually do, so let's, shall I write anything? Yeah, so this is our claim. So we said that marginal product of labor intersects average product of labor at its maximum. So if you want to find the maximum of a function, what do? What do we do? You take, don't worry, it's not a tricky question. You take the derivative and set it equal to 0, right? So let's try to get average product, right? So which was basically this. Let's call this f of Lk divided by L, okay? So this is average product of labor. I'm going to take the derivative of this, right? So basically, so this is the average product of labor. Now I'm going to take the derivative and then set it equal to 0, okay? So this guy's derivative, okay? So let's call this. And then we would like to figure out, where it reaches its maximum, okay? So now let's do this. So basically, let's do this. So if I take the derivative of this guy, so how will I take? So you see that it's actually, right, so this is basically, you have a numerator and a denominator, right? So what is it? So if I want to take the derivative of this guy with respect to L, what do I do? First I take the derivative of this guy, right? Del F over del L, right? Times L plus, minus, right? So then I keep this guy the same. F of Lk times 1, right? Divided by L squared. So then I take this into 1 over L parentheses, right? So this and that would go away. So I would have del F over del L, 1 over L, right? And then here I have, if I take it into F of Lk, oh, there's no 1 over L, right? So this L and this guy go away. I put it here. And then this is going to be F of Lk divided by L, right? So I said that if I want to find the maximum, I should take the derivative and set it equal to 0, okay? So what is this? Of course, given that L is not equal to 0, what is this guy? Marginal product of labor. What is this guy? average product of labor. You see that in the maximum, right, that this should be equal to 0. So this guy should be equal to this guy, right? So, and you also see that suppose, marginal, so when this is, suppose this guy is equal to this guy, so we know that APL is at its maximum, okay? And what about this? When MPL is greater than APL, then? So if this guy is greater than this guy, this is going to be greater than 0, right? So this derivative, so you can actually call it like this, del APL del L is positive, right? So let's put this, if these guys are equal to each other, so let's put it like this, del APL del L is equal to 0, right? APL reaches its max, right? And then we said this, so here we say APL is what? When marginal is above the average product of labor is increasing, right? So if you want to show that a function is increasing, you take the derivative, and if you take the derivative of that function, and if it's positive, right, the derivative is positive, you say that function is increasing, right? APL is increasing. And then again, when we have MPL is less than APL, del APL del L is negative, right? So you see this determines everything. And then we know that average product of labor is decreasing, right? When marginal is below the average should be decreasing, okay? So this is important because at some point we need to draw these curves, especially the cost curves, which we are going to see. And then these concepts would help you, okay? So there you would have marginal cost and average cost curves. And so these concepts are very important, okay? So just keep this in your mind. But as I said, that intuitively it all comes from this simple logic, okay? Now, remember again in the consumer theory, we had our good old, when we had this utility function, right? And we had our what curves in the consumer theory? Indifference curves, right? So they were all the combinations of x and y, which were giving some utility level u0, okay, u bar. So basically we had these indifference curves, so y, x, right? So we had these guys, so call them u0, u1, u2, okay? And we had these nicely shaped indifference curves, but we know that under what conditions we would have these nice shapes, right? You don't have to. So these are just, nice assumptions so that we can use, like differentiation and such, right? So these, so that things are differentiable and such. So actually, we would have a very similar concept here. So this is your production function, okay, which is equal to Q0, right, whatever. So again, this is how you're going to get an indifference curve. You're going to set it equal to 3. Then it's going to give you, for instance, all the combinations of labor and capital, which are going to produce 3 units of that good, okay? So in this case, these guys were called indifference curves. Here, these guys will be called, so let's put capital here, let's put labor here. Again, we're going to have these sort of guys, okay? And these guys would be called isoquants, okay? So they're called iso. You know what iso means? Iso means equal, right? So eş. So like, so it's called iso, and quant means quantity, right? So these are basically curves of the same quantity. It's showing all the combinations of capital and labor giving the same amount of production, okay? But remember, in utility theory, do these numbers mean anything in the utility theory, right? U0, U5, like U5, U3, whatever, right? You said no, right, hocam? Because in the utility theory, everything was what we said, ordinal, right? Not cardinal. But here, for Arçelik, do you think this number means anything? Yes, right? So it's like literally how much they're going to produce, okay? So just keep that in your mind. And these curves are called isoquants, right? They are showing all the combinations of capital and labor such that you can produce, let's say, 100 coffee machines, okay, or 100 salads at Mozart Cafe. So depending on your production technology, of course, this F, right, your function, and which we said that is determined by our clever engineer friends, okay, we take it as given. So depending on that technology, we actually, it might be the case that you can produce, at Arçelik or at Toyota or at Mozart Cafe, you might be producing the same amount, like let's say, or at Tadım Pizza, with like, let's say, 2 workers and 10 ovens, and or you can actually do it with like 15 workers and with 3 ovens, okay? So depending on that technology, we don't know what that is, okay? So as you can guess, what's going to happen to these quantities? Remember, in the also in the consumer theory, what was happening to utility in this direction? Increasing. But we said that under which assumption? More is better, right? Otherwise, we don't know. So here, similarly, again, if you assume that these guys are, again, there is sort of more is better in this case as well. And so you see that quantity is going to increase in this direction, okay? So you see that it's very similar to whatever we have learned. So, okay, so remember, how were we calling these curves? So the slope of these curves. So what was this slope called here? It was called marginal rate of substitution, right? So here, remember, slope of the indifference curve, actually absolute value of the slope of the indifference curve was called MRS, right? And it meant that, if I want to stay on the same utility level, but I would like to consume 1 more X, okay? So, or for 1 more X, how much Y I'm willing to give up, right? So that was the idea of the marginal rate of substitution, just as we had it there. So here, this was slope of the indifference curve. It was basically, we called it minus dy dx when you keep the utility level at u bar or u0. Okay, so this was called MRS. Here, it's going to be called, slope of isoquant. It will be called marginal rate of technical substitution, okay? So, and it's the same concept, okay? It's just now the jargon is a little bit different. So this is called marginal rate of technical substitution, okay? And this is going to be minus, so this is dk over dl, okay? And this is going to be marginal rate of technical substitution. And here you keep the quantity at some level Q0, okay? So basically it's only you put this technical, but it's the same concept. So suppose 1 more unit of labor is now available. So suppose that you want to produce the same amount, how much of your capital you're willing to get rid of, okay, or you're willing to give up, okay? So that's basically the same, okay? So you see that nothing is different here. So, okay, again, in consumer theory, we knew that this marginal rate of substitution was equal to what? It was equal to, so if you want to compute the marginal rate of substitution, how would you compute it? Right, so it was the ratio of the marginal utilities, right? So this was basically marginal utility of X divided by marginal utility of Y. Okay, so guess what's going to happen here? This is going to be the ratio of the marginal products, right? So marginal rate of technical substitution is going to be the ratio of MPL, MPK, okay? And remember how we proved it for marginal utilities. Remember we used the implicit function theorem. So here you can easily show it as well, okay? So by looking at how we showed it, you can actually show this guy as well, okay? So this is basically, you see everything is very much the same. That's why I said that we're going to spend a lot of time on consumer theory, and then the firm theory is going to follow very easily, okay? So now, remember there was this idea between the diminishing marginal utility and diminishing marginal rate of substitution, right? So do you remember whether they were the same thing or not? So again, in consumer theory, so we said this, diminishing marginal utility of X, marginal utility of Y, okay? And then we said versus diminishing marginal rate of substitution. So were they the same thing? They were the same. Were they? Remember, this was your quiz question. So this was diminishing marginal utility of X, diminishing marginal utility of Y, right? So the fact that we have, you can see this here immediately, right? Just because this guy is diminishing and this guy is diminishing, does it require this guy to be diminishing? No, right? I mean, this could be diminishing, this could stay constant, right? And then, or, you know, it depends. We don't know, right? So the fact that you have diminishing marginal utilities, it doesn't mean that there will be diminishing marginal rate of substitution, okay? Similar logic applies here. So diminishing, right, marginal product of labor, diminishing marginal of capital, product of capital versus diminishing marginal rate of technical substitution. So these guys are not the same, right? It doesn't, one does not need to bring the other one, okay? So remember here we actually wrote down, so what was diminishing MRS? Was corresponding to. Remember, it was corresponding to many things, but the most important thing that diminishing marginal, if there's diminishing marginal rate of substitution in difference curves, we said are convex, right? So we can have this, you see here you have diminishing MRS, right? So the slopes are actually decreasing, right? So the absolute value of the slope. So basically here, so like again, if there is diminishing marginal rate of technical substitution, then we're going to say that isoquants are convex, right? Actually, strictly convex. Depends on how you define convexity, okay? But strictly convex, okay? We said that. So we have these nice, when we have these nice isoquants, you see there's diminishing. So as you have more and more labor, the amount of capital you're willing to give up when there's another unit of labor is out there available, and if you want to produce the same amount, at some point Mozart Cafe would say, if they had lots of ovens, they can say that, oh, okay, I can hire another labor, and I'll give up, you know, 2 of my ovens, right? So I'm going to give it to my, you know, brother's Mozart Cafe, Mozart 2 Cafe, whatever, okay? So it's, but as I keep on hiring more labor, then the amount of capital that I'm willing to give up at some point is going to decrease, right? So basically, we actually said that there is diminishing marginal rate of technical substitution. As you have more labor, the amount of capital you're willing to give up is going to decrease, right? Which means that your marginal rate of technical substitution is going to decrease, okay? So this is what we said, the isoquants are strictly convex, right? And it meant that if there is diminishing marginal rate of substitution, here indifference curves are strictly convex. And, or we actually said that, what does it say about the utility function? Utility function is strictly quasi-concave, right? Utility function is a strictly quasi-concave, and here isoquants are convex, or we can say that this function f is production function is strictly quasi-concave, right? So it's similar. Production function is strictly quasi-concave, okay? And remember, in the consumer theory, if you check your notes, you'll see that the definition of, or the condition, so that you would check for quasi-concavity, there you could impose, you know, u of x is positive, u of y is positive, right? And you also have u of xx is negative, u of yy is negative, okay? But also, what brings diminishing marginal rate of substitution was also depending on this cross partial derivative as well, right? U of xy. So what was this? Okay, so it was, is it positive, is it negative? And if you apply the same condition here, again you would see that it's going to be f of L negative, f of, so we know that f of L is positive, f of k is positive, f of L, f of ka, kk is actually negative. So this means diminishing, right, marginal productivities. Again, if you check for the condition of quasi-concavity, you would see that this should depend on also this guy, right? Exactly, so what is this guy? The sign of this guy, right? And this is exactly what you guys were telling me. Oh, hocam, this is this. So when capital changes, right, how does the marginal product of labor is actually, how does the productivity of labor changes, okay? So this is basically the case. So it depends, that's why the fact that you have these guys is not enough to have the marginal rate of technical substitution to be diminishing, okay? So these are, you see these concepts are very, very similar, okay? So basically, and if you just, don't worry, you know, like I never ask this, but just to remind you, so the condition for quasi-concavity was something like this. So if you check your notes in the utility theory, and then we'll give a break. So if you check the conditions for that, you would see, so it was, the condition was something like this. So basically it was, so it was something like this, f of k squared, okay? So basically minus 2 f of lk, f of L, f of k, okay? Plus f of kk, f of L squared, okay? So we wrote this with u's, okay, in consumer theory. And it turned out that in order for the function f or u to be quasi-concave, so this was the condition, okay? So you see that this guy is negative, this guy is a square, it's positive. This guy is negative, this guy is a square, positive. You see it's good that this part is negative, this part is negative, but we don't know what's happening here, right? So this guy is positive, this guy is positive, but you see it would depend on this guy, okay? So that's why the fact that you have diminishing marginals doesn't mean that you're going to have the marginal rate of substitution or marginal rate of technical substitution is going to be diminishing as well, okay? So just keep this in your mind. Don't worry, I don't ask this. Recall from utility, okay, theory that we have done this, okay? So you see that it's actually very similar, and it's important that this was the stuff that Malthus had missed, right? So it's important that how productivity of labor is of an input is going to change when you keep on the amount, you know, changing the amount of, let's say, capital, right? So things are, and this is what happened in the world. That's why we don't have to be that pessimistic, because as we had more and more capital, labor productivity increased, okay? So Malthus was too pessimistic, okay? So we'll continue with returns to scale ideas.